Welcome to this explainer. Today, we're tearing into the colossal power generation system of a Category J jackup rig. But hey, instead of just looking at a massive pile of cold metal and wiring, I want you to picture this structure as a living, breathing organism. We're going to explore exactly what pumps its blood, what controls its muscles, and how it survives in one of the most punishing environments on Earth, the North Sea.
We're taking a guided engineering tour right through the rig's energy flow. We'll hit the floating power plant, dual engine rooms, SCR and VFD control, the electrical backbone, and finally, the electrification leap. Let's get right into it.
Section 1. The floating power plant.
To really grasp the sheer scale of this beast, you have to remember it sits up to 150 meters above the freezing ocean. It might look static, but it operates quite literally as a massive floating power plant. Every jacking unit, every drilling motor, every mud pump, and every single light in an accommodation block housing over 120 people runs off one massive electrical system. To keep all those muscles moving, this rig burns through enough diesel to power a small town every single day.
Section 2. Dual engine rooms.
Let's step inside the mechanical heart. The raw math behind this power is just staggering. We're looking at a standard Category J setup here. 4 massive diesel generator sets pumping out around 2,500 kilowatts each, teamed up with 2 more rated at about 1,750 kilowatts. But the real kicker isn't just the sheer brute force, it's the architecture. These units are intentionally split completely across 2 separate engine rooms. So quick check for you. Picture a worst-case scenario. You're in the middle of a brutal North Sea storm, and a fire, severe flooding, or a catastrophic mechanical fault completely takes out one of those engine rooms. What happens? Does the whole rig go dark? Do you lose control of a live well? Thankfully, absolutely not. Because of those dual engine rooms, a single room failure simply does not equal total power loss. The second room's generators immediately keep right on supplying the critical loads. We're talking jacking systems, drilling operations, and all your critical safety nets staying online. Listen, redundancy here isn't just some nice-to-have upgrade. It is a strict, harsh environment design requirement, not a luxury. That's the entire point of splitting generation physically apart.
Section 3. SCR and VFD control.
Now, you absolutely need to know these terms to get how the rig's nervous system actually works. SCR, which is silicone-controlled rectifier, and VFD, or variable frequency drive. Think of these as the brain mechanisms of the electrical grid. They take that raw, massive output from the diesels and precisely convert and regulate it for the large AC and DC motors all over the rig. This is the secret sauce that enables smooth, controllable, and efficient variable speed operation. The real genius is the contrast here. On one side, you have the absolute brute force of those generators, cranking out massive raw power. On the other, extreme precision. You've got a drawworks hoisting engine maybe rated at 5,750 horsepower, and a top drive turning the drill string that needs over 92,000 foot-pounds of torque. The SCR and VFT controls guarantee these individual big motors get exactly the speed and torque they need at any given millisecond. No more, no less. It's just a masterpiece of precisely metered power.
Section 4. The electrical backbone.
And this builds directly into the rig's electrical backbone. Every single muscle we've covered relies on this exact same nervous system. The massive mud pumps blasting fluid thousands of meters downhole, the rotary table, and those insane electrical rack and pinion jacking units that literally lift thousands of tons of steel right out of the ocean, they all draw from this one single power backbone.
But because everything runs through this single backbone, the inherent risk is off the charts. Lose power management here, and literally every other system on the rig is affected simultaneously. You lose the ability to drill, the ability to lift, and the ability to stay safe. Which is exactly why the power generation redundancy we talked about earlier sits at the absolute center of the entire Category J design philosophy. Everything hinges on keeping the lights on.
Section 5. The electrification leap.
Now for the really wild part. Up until recently, this heavy diesel paradigm was just the way things were done. But in 2024, one sister rig, the Askapot, did something no harsh environment jackup had done before. It switched its engines off entirely. Through a massive engineering feat, they converted a mud treatment room into a high-voltage electrical room and linked the rig via cable to the Martin Lindsay A platform, which gets its power directly from shore. By running almost entirely on shore power, the Askapot slashes roughly 20,000 tons of CO2 emissions annually. That is a total game changer for a heavy industrial machine.
But a lot of people get this completely backward. You hear electrified rig, and you might assume they just toss the diesel engines overboard. Not a chance. As the experts point out, shore power does not mean zero backup generation. Electrification doesn't mean zero onboard diesel. Those powerful backup generators are kept primed and ready because a manned offshore installation can never, ever be left without power. If a shore cable faults, rare but possible, the rig's internal heart has to start beating again instantly. So, the overarching takeaway from this explainer? Safety redundancy evolves. It might shift from offshore to onshore, but it never ever disappears. The engineering just gets infinitely smarter. We've gone from burning enough diesel to power a small town to plugging a floating skyscraper directly into the grid, all without compromising safety. Which leaves us with a pretty massive question. With this proof of concept now surviving the harshest conditions, what other colossal offshore machines are ready to make the leap to shore power next?